Hello everyone, welcome again to Ramanujam School of Studies 0 to Infinity. Today we will learn about the basic concept of chemistry, and we will start our lecture with the chapter 2, that is methane. And here we will see the basic concept in which we will deal with free radical mechanism, how free radical mechanism is essential for chemistry, organic chemistry, and we will see the energy of activation, transition state, and a lot of things we are going to discuss in this chapter. So first of all, we here start with our lecture with hydrocarbons. Let carbons. See here, hydrocarbons. Hydrocarbon means hydrogen and carbon. So such a compound which is made of the elementary element, that is hydrogen, whose atomic number is 1, and carbon whose atomic number is 6. So hydrocarbon is our organic compound which contain hydrogen as well as carbon. Okay, so certain organic compound contain only two elements, that is hydrogen and carbon, right? And hence they are known as hydrocarbon. On the basis of structure, hydrocarbons are divided into two main classes. So hydrocarbons can be divided into two main classes, and the criteria for this division is the structure of hydrocarbon. And we have two families. First of all, we can write here this hydrocarbon can be divided as aliphatic, that is aliphatic hydrocarbon. Okay, and second division, that is family, is aromatic hydrocarbon. Okay, so what is the basic difference between aliphatic hydrocarbon and aromatic hydrocarbon? Basically, the structure of aliphatic hydrocarbon is open. Okay, so it contains chain, branch chain, and saturated and unsaturated bonded, but there is not extra stability in aliphatic hydrocarbon. As well as if we talk about the aromatic hydrocarbon, it has extra stability, that is the resonance structure existed in the aromatic hydrocarbon. And here you can see that this is aromatic, that is this is aroma. So aromatic hydrocarbon must contain some specific type of aroma like benzene, toluene, phenolphthalein. These compounds contain aroma as well as basic stability. It is a stability due to the resonance. Now further, aliphatic hydrocarbon is divided into alkane. See here, alkane. Okay, further alkene, alkyne, and cyclic alkane, that is the cycloalkane. Cyclic aliphatic, we can say that cyclic aliphatic, right? So the basic task here we have to learn about the aliphatic hydrocarbon, and the chapter here is we will discuss later, that is alkane. And in this chapter we will discuss more about the simplest alkane, that is methane. Okay, methane. And methane contain single carbon atom and 4 hydrogen, that is CH4. So what we are going to discuss here, that is the structure of methane, properties of methane, that is the chemical properties of methane, physical properties and of methane, chlorination, that is the halogenation of methane, oxidation of methane, and lots of more. In this chapter we will discuss more about the transition state. Okay, and we will see how reaction proceed with the energy requirement and many more. So the simplest member of alkane family is one of the simplest of all organic compound, that is called methane. Okay, one of the simplest organic compound, that is CH4. Now carbon has an unpaired electron in which of the p orbital. See here, in order to understand the structure of methane, we must know the electronic configuration of carbon. As we know that carbon atomic number is 6, and these atoms, these electrons, that is 6 is total number of electrons in of carbon, and these 6 electrons are arranged themselves as like this, that is 1s, 2s, see here this is 2s, and we have 3 2p orbital. Okay, now one has 2 electron in paired one, 2s is also have 2 electron in paired one, and we have 2p, that is 1 electron and 1 electron. So in this ground state, carbon has only 2 unpaired electron, and if carbon has only 2 unpaired electron, it may form compound like CH2, which is not formed generally. So in order to explain the formation of CH4, we take the atomic configuration, atomic configuration in excited state. So in excited state, one of the paired electron of 2s orbital promoted to the next higher energy level of 2p. So in excited state, we have 4 unpaired electrons. See here. Okay, so these are the 4 unpaired electron. So one is in 2s, and this is 2p, this is 2p, and this is 2p. See here, we have different 2p because in 3-dimensional, the orientation of p orbital may be in x-axis, may be in y-axis, or in z-axis. So any one of these orbital may be x-axis. So we can write here 2p x, this is 2p y, or this is 2p z. It is not mandatory that this must be 2p x. This one must maybe 2p x. So we cannot define here which is 2p x. Any one is 2p x, or any one is 2p y. Right? When these unpaired electrons merge together, that is mixing takes place. That is mixing takes place, and mixing means hybridization. Hybridization. So the concept of hybridization is mixing of atomic orbital, and it produces 4 equal energy level hybrid orbital, that is sp3, because one of s orbital mixed with 3 of p orbital, it formed 4 equal energy orbital, that is sp3 orbital. Okay, so we can write further here. See here, in simplest form, the atomic configuration of carbon after mixing, this is 2s, and we have 1 2 3 4, and these 4 are hybridized, sp3 hybridized orbital, each containing single electron, that is unpaired electron. Now the most important concept is how are sp3 orbitals arranged in space. So see here, the structure of these are sp3, 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 and sp3. Now question is how these sp3 are arranged in space. So see here, this is very important. This is x and y axis. Now if we represent sp3 orbital in 2 dimension, we have like this one. See here, this is very important. Wait a minute. This is sp3. So this is the smaller lobe, and this is larger lobe. If we denote it in a electron cloud, so we can write it as like this one. Very important. Electron cloud is very important because these electrons are moving. So we can write here, this is the electron cloud. So this is the smallest lobe, and this is the larger lobe. So sp3 have 2 lobe, as you understand. Now these all orbital, 4 orbital, are spaced in space in tetrahedral shape like this one. So see here, this is very important. right? This is the shape of tetrahedral, and we have like this. Okay, this is sp3 orbital, hybridized orbital, and carbon is at center. Okay, so in sp3 hybridized we have 4 sp3 hybridized orbital, and each contain a single unpaired electron. Okay, single unpaired electron like this. Now when hydrogen comes near to these sp3 or hybridized unpaired sp3 orbitals, what happened? Mixing takes place between sp3 hybridized orbital and s orbital of hydrogen, and this is the mixing of 4 hydrogen atom with 4 different direction of sp3 hybridized orbital. So this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. This mixing create form a sigma bond, that is the stronger bond, but this sigma bond is directed one. This sigma bond is directed one, but it is the weaker bond when we compare to the ionic bond. So we have the structure of methane like this: C, H, 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 and this is H. This is the tetrahedral shape. Now the most important thing here, we have to remember that the bond length between any one of these, that is HCH, either this one, or HCH, either this one, or HCH, that either this one, or HCH, either this one, all bond angle are equal, and each angle is equal to 109.5 degree. And if we consider the bond length between C and H, so the bond length of C and H is 1.1 angstrom. Okay, very important, right? The angle between any pair of bond, right, is 109.5 degree, and bond length, each bond length are equal, and each bond length are equal to 1.1 angstrom. And if we have to break this bond, CH bond, we have to provide 104 calorie, 104 calorie, 104 kilocalorie, right, per mole. So in order to break, we have to provide a large amount of energy to break the bond between CH. Hence it is strongest bond, because we have to provide large amount, 104 kilocalorie per mole, right? Now this bond CH4 is sigma bond, and sigma bond is directed one. So in a nutshell, we can say that during the structure of methane, the 2s electron is promoted to 2p electron, and we have 4 orbital, each containing 1 unpaired electron, which after mixing, that is the after hybridization, produces 4 equal energy sp3 hybridized orbital, which are directed along the tetrahedral shape. When s orbital of hydrogen comes near to the sp3 hybridized orbital, it mix up together, that is overlap, and overlapping, this is the head-on overlapping, creates sigma bond, and each bond are equally spaced, and each bond length is equal to 1.10, and having each angle is 109 degree Celsius. This tetrahedral shape is like this tetrahedral shape is arranged in such a way that there is minimum repulsion between the bond electron, that is C and H. So, and maximum repulsion and minimum energy, and the shape so occurred is sp3 the shape so occurred is tetrahedral one. I hope you have cleared the concept of the structure of methane. Now in next lecture, we see how these structure is the base for the physical properties as well as chemical properties of methane. If we learn the basic of the physical properties and chemical properties of methane, we extend this concept to the higher alkanes, that is ethane, propane, butane, and moreover. And these properties is also useful in determining the properties of families of alkane. To study the physical properties, what we need to study first is polarity. 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 Okay. And in order to understand the polarity of a compound, we must know about electronegativity. Electronegativity of an atom. So, we start our lecture from the electronegativity of an element. So, electronegativity is nothing, it is the power of any atom to attract electrons toward itself, right? That is the power. Power to uh, pull electron cloud to itself. When there is two hydrogen molecules, suppose we have one hydrogen and another is one hydrogen atom, and when they come nearby, suppose here, see how covalent bond is formed. Hydrogen is like this one, this is nucleus, and electron is moving in this orbit for first hydrogen, and for second hydrogen electron is also moving. Okay, now what happened when both hydrogen comes together? When both hydrogen comes together in contact, right, like this one, so if the electron of this hydrogen 2 comes at the center, it experiences two forces from two nuclei, that is nuclei 1 or nuclei 2. So in their movement, this electron may be moved in the nuclei, in the orbit of its original, that is hydrogen 1, or it may be in the second. So what actually it moves? It moves like this one. Okay, so it may be like this one. This electron may be anywhere in the premises of the effect of both nuclei, and here the attraction force on any electron is due to both the nuclei, and this is known as hydrogen, that is covalent bond. Right, now what happen if we have in place of hydrogen we have chlorine? Okay, so in this case chlorine has more power, more energy to attract electron toward itself. So the electron cloud between the hydrogen and chlorine is moved toward the chlorine, and it is like this one. See here, this is the pictorial graph. Okay, so density of the bond electron is more toward chlorine as compared to hydrogen. This creates a partial negative charge on chlorine atom toward electron is attracted, and partial positive charge toward to those whose electronegativity of atom is less. So in order to understand some electronegativity, we have to learn, that is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. We take some important value of electronegativity. So hydrogen, it has electronegativity 2.2. Helium, it is no data because it is this helium is inert gas, no data. Lithium being a metal having electronegativity somewhat lower, that is 0.98. Beryllium is 0.1, 0.57. Boron, and this is 2.0. Okay, carbon has 2.55. See here, these are some basic data of electronegativity. Nitrogen has somewhat more electronegative, that is somewhat more sorry, power to attract electron. Oxygen, it has electronegativity 3.44, and finally fluorine has electronegativity 3.98. all right, so I think this fluorine has the most electronegativity and electronegative atom. Okay, now due to the electronegativity, that is the power to attract the electron cloud between the molecules, between the nuclei of the molecules is polarized, and due to this polarity comes in play, right? So one thing, if we have hydrogen and fluorine, so the covalent bond between the hydrogen and fluorine, that is the two electron, is polarized toward fluorine, and fluorine have minus, negative, delta minus, and hydrogen has deficiency of electrons, so it has delta plus charges. Now suppose this is a bond length, that is d, so we have a very important concept that is called polarity of bond, which is defined as in dBi. Unit of polarity of bond is dBi, and this is equal to electron e charge on atom. These are equal charges multiplied by d. So this is the polarity of bond. Okay, this polarity play very important role in the properties of the many molecules. So here we take charge in ESU, and here the distance is taken in angstrom. Okay, and the polarity comes in dBi. Very important concept. Okay, so due to polarity, molecule may be polarity, molecule may be polar or may not be polar. How this can be possible? See here, we have a molecule. Suppose suppose methane. We take the molecule methane. We have two molecules. Suppose we take a molecule HCl. Here bond is in between HCl, and the electron cloud is toward chlorine. So there is some polarity. We have dipole moment. This is called the dipole moment. This is dipole moment. So here in HCl, electron is toward chlorine atom. So we have dipole moment is not equal to 0. There are some value of dipole moment. But what in case in CH4 molecules? See here, the CH4 molecules, if we analyze the single bond between C and H, carbon here you see that 2.5 and hydrogen is 2.5, nearly equal, but carbon has more power to attract the electrons. So electron cloud is somewhat toward the carbon, and it creates delta minus on carbon and delta plus is on hydrogen, and it has a little bit dipole moment. Again here dipole moment is not equal to 0, but in case HCl is polar molecule, but CH4 is non-polar molecule. Why? Molecule, because the CH4 molecule is very symmetrical one, because here we have four bond, CH bond, and each bond is toward the vertices of regular tetrahedron. So the dipole moment, if we see that the dipole moment is a vector quantity, so in case of molecule we have to analyze all the dipole moment, that is we have to calculate the vector sum of all the dipole moment. So see here, this is the dipole moment, this is the dipole moment, and this is the dipole moment, and this is the dipole moment for each of CH bond, and each of the CH bond in net result, that is if we do the vector sum of each dipole moment, it must be equal to 0, being symmetrical molecule. So the CH4 molecule is non-polar molecule. So when CH4 is non-polar molecule, its property is a bit difference between polar molecule as compared with the NaCl or HCl. Now what are the properties of non-polar molecule like CH4? So one of the important concept is here, like dissolve like. If we talk about the solubility, so we have to take consideration like dissolve likes. What do you mean by like dissolve like? So if we have solute, polar solute, it means these polar solute must be dissolved in polar solvent. So if NaCl if we have to dissolve in NaCl, it cannot be dissolved in benzene, but it readily dissolve in alcohol and water. If we have to dissolve non-polar molecules like methane, so we cannot dissolve non-polar molecule, that is like methane, in water or alcohol, that is the polar molecule, but it can be dissolved in non-polar solvent like benzene and toluene. So we write here like dissolve like. So these molecule, non-polar molecule, dissolve in non-polar solvent, right? First properties is this. And if we talk what is the state of CH4, So in order to analyze the state of CH4, basically we know that the CH4 molecule, that is methane molecule, is methane gas. Why it is a gas? Why it is not a solid or a liquid? It depends upon the attractive force between the molecules. Being non-polar molecules, only van der Waal attraction force being van der Waal attraction force play a role in the attraction between the molecules. Either it is intramolecular, right? That is the intramolecular forces is due to only van der Waal force. There is no any Coulombic forces, that is attraction forces like an HCl. Since van der Waal force is very weak and it easily overcome by the thermal energy. So being very weak force, the CH4 molecule at the room temperature is gaseous molecules, because energy, when energy is supplied to this molecule, its intermolecular force is broken down. So at room temperature it is a gaseous. And if we talk about the what we say that melting point and boiling point, so due to these weak forces, melting point of methane is 182 degrees Celsius, nearly with minus sign. That is, we have 0 to, we have to move 182 step backward on the scale, temperature scale, minus 182 degrees Celsius. And we talk about the boiling point, it is somewhat larger, that is minus 161 degrees Celsius approximately. This is an approximate value, but this melting point is minus 182 degrees Celsius and boiling point is minus 161 degrees Celsius. Right in between the molecule, the CH4 molecule is in liquid state, and below minus 182 degrees Celsius it is in what state? Solid state. So we have melting point and boiling point, and what role play? Again, the melting point and boiling point, and why methane is a gas at room temperature, all are depends on the intermolecular attraction force, that is van der Waal forces. I hope all the concepts are clear here. And one more thing is, methane is a colorless gas, right? Is colorless gas. One must be noted, methane is a colorless gas, and one thing is, methane is less dense than water. Okay, lighter than the water. So specific gravity of methane, if we talk specific gravity, so specific gravity is 0.04. Specific gravity is nothing, it is the relative density with respect to water. Being methane is less dense, it is easily overcome over the water, like that. So it is very less dense than water. I hope all the things here is clear now. Why methane is a gas, why it is a non-polar molecule, what factor play roles, that is in the non-polar molecule, that is electronegativity. Being a polarity between the bond, it may be polar and it may be non-polar. Why it may be non-polar? When all the dipole moment, that is the resultant of all the vector sum of dipole moment, is 0, then molecule will be non-polar. And the most important concept is like dissolve like. It means if solute is polar, it must be dissolved in the polar solvent. If solute is non-polar, it must be dissolved in the non-polar solvent. And in methane, the only force is van der Waal force, which is very weak force and very weak intramolecular forces. The molecules intermolecular forces, the molecule, that is the methane, is a gas. Melting point is very low and boiling point is also very low. I hope you understand this lecture, you enjoy this lecture, and if you like this lecture, please hit the like button and please share and subscribe all the videos whatever released to you. In this in the next chapter, we will learn about the chemical properties, and all these properties must be enhance these properties in the other concept of alkanes. Okay, so have a nice day. Jai Hind.